So let's have this here to solve this question. So the second question here say what? Here is the data. Okay, in this case, I need to make a design with 8 classes, right? So if I have 8 classes, then I need to start getting the class widths, right? So how do I get the class widths?
The lower limit?
Yeah, I need to know the lowest value and the highest value. So what is the minimum value here?
0.5.
The smallest value here is 0. Did you see 0.4? No, 0.5. And then the highest value, the maximum, is 4.0, right? So the range R is the difference between them, 4.0 minus 0.5, which is 3.5. Okay? And then I need to divide this by the number of classes required. He wants 8 classes. To get what? To get the class width. So the class widths, CW, is actually approximately the 3.5 divided by 8, where the 8 is actually the number of classes. The number of classes, given in the question here. 8 classes. Okay? So this gives me how much? This is approximately equal 3.5 divided by 8, how much? 0.4. No, we need a calculator for this. So
0.4375. It's down, teacher.
Where's the calculator? Calculator is here. Okay, so we need 3.5 divided by 8, so that would be equal to 0.4375. 0.4375. That's it. Okay, or 0.476. So if this is that's actually not approximate. This is approximate. So how much you're going to select it? We need to take a higher value, little bit higher value, and this higher value should be similar in precision to here. What is the precision here? You see the decimal points here are 1 decimal place, right? This is my data, right? This is my row data. So if I have 1 decimal place here, then I should also have 1 decimal place here. So what is the higher value with 1 decimal? Yeah, 0.5. So they will make it actually 0.5. This way it's actually 1 decimal place, yani 1 digit after the decimal point, like here in the data, and it's also higher. And anyway, you make this as a suggestion, and then we can test to see if it will work or not. So how do you make a test if it will work or not? It will work if you have total 8 classes, the lowest value in the first class and the highest value in the last class. Then it will work. So let's do that. The smallest value, starting the class limits. From the lowest value, which is 0.5, right? And then the next class, you need to add the class width, so we'll start from 1. See, we add vertically, right? And then 1.5, right? And then 2, and so on. So from the first one, from 0.5 till
0.9
to 0.9, of course, because the new class will start from 1, right? And then remember, the class width, that one is actually used to add the distance vertically. Just keep adding here, the 0.5, okay? Adding 0.5. So now I'll keep doing this until I reach the last class. This is 2.5, and then 3, and then how many classes I should have? 1, 2, 3, 4, 5, 6. I need 2 more, 3.5 and 4. That's it. Okay. This, of course, should end at same thing. I should put 0.5. I keep adding 0.5, so this will be 1.4, and then 1.9, and then 2.4. And then 2.9. Just keep adding 0.5 also, because the vertical distance is the same thing also here. So here also you just keep add 0.5 as well, right? So that would be here 3.5, sorry, 3.4, then 3.9, and then 4.4. That's it. So this is the last class. Now I need to do the difficult task of finding the tally, the counting how many value in each cross. So here I'll do the tally and frequency by simply checking every value and put it in the right place. So here I have 2. So where is the 2? It's over here. So I make a mark here. You see that?
Yeah.
And then I see the 3.1, sorry, so will be here. In this class, right?
Yeah.
This is 3.4. And then I see this one, 2.2, which will be here. And then this one, 3, which will be here. And then 3.2, where's 3.2? Will be also here. And then 2.4 will be here. And then 2.2, which is, do you see what I'm doing? Anyone have a question about that so far? Is that okay? And then a 4.1, or 0.0 actually, 4.0, so it will be actually down. So 4.0 is here, that's it, okay? And then I keep doing this. Anyone did this until the end?
Yeah.
Okay, can you tell me the frequency now? When we finish this at the end, till the end, and we do the frequency will be, first class is 4, 2, 7, 9, 2, 10, and then 2. Anyone have a different opinion about that? Is it the same? How many did like this? Okay, same. Okay, very good. So this will be the frequency. Anyway, you can check also one way to check. It doesn't, sometimes you have a mistake that the check that passes the check, but also a good idea to do that. So 4 plus 2 is 6, 6 and 7. We just add the frequency. You give me 13 and 9, 22, and 12 is actually 34, and you have 6 more, so that's actually 40. So the data are 40 because you have 4 values here and you have 10 values here. So that's why it's actually equal to the data size. So the sum of the frequency is actually equal to 40, which is actually equal to the data size n. So that's one way to check. Yeah.
So, in one of your videos, you explained the end of one class with, let's say, 2.4. It was 2.5, and then the start of the next class is the end of the previous one.
It's not exactly the end. There has to be a gap. If you're using class limits, there has to be a gap. So there is a gap. There is a gap here between this one and this one. This gap here. This gap because we're using the class limits. If we are using the class boundary, then the class boundary actually closes this gap because the boundary comes in the middle of the gap. Okay, so it depends on how am I representing the class. If this number here is exactly the same number here, then this is not class limits anymore. This is called class boundaries.
Oh, okay, thank you for that.
Yeah.
So you would use class boundaries for continuous.
Sometimes it depends on the application. Sometimes class boundaries are used. Sometimes class limits are used. Usually the limits are used. Okay, whether they are continuous or discrete. Okay, so I got the frequency. Now he want me to graph what? What is the question? He want me to graph the frequency pollution, right? Construct a frequency pollution. So we need to graph a frequency pollution, right? Okay, so now how am I going to do that? I'm going to take the midpoint and the frequency, right? So in this case, I need the midpoint as well, right? Frequency pollution. So in this case, I need the midpoint. What is the midpoint here for this class? You add the limits and divide the results by 2. So the average of 0.5 and 0.9 is actually 0.7, right? Just add them, get 1.4, and when you add them, divide after that by 2. So the answer will be 1 over 1.4 divided by 2 is 0.7. It's halfway. The average is halfway between the two values. Always the average is the midpoint of two values, right? So that's how I get the midpoint here. Same thing, I can just keep adding 0.5, right? Any question here about this midpoint? Just keep adding 0.5 because the class width is 0.5 and it's also the distance between classes. So just keep adding you know, 0.5, so it would be like that, 1.2, 1.7, 2.2, 2.7, and so on, okay? So this will be at the midpoint, 3.2, 3.7, 4.2. Okay, so this is the midpoint. This is what I'm going to use actually in my graph. So if you do that, you graph the midpoint with the frequency, so you're going to have a graph like this. Okay, you're going to have a graph like this. Okay, where the midpoint is actually starting from 0.7, and then 1.2, 1.7, 2.2. See, this is the midpoint, right? Like what we did before here. The 0.7, the 1.2, and so on. And the frequencies are the 4, 2, 7, 9. The highest one is 10. This is the highest frequency here. So, and then you connect all these points together. You know, this is the 4, this is the 2, you know, this is the 4, this is the 2, right? And then after you do that, you connect all this together so you get the frequency pollution. Okay? When you do that, you don't worry much about the scale. If I want to start that from the beginning, I'll just have to put the number of classes here as midpoints. Just equal distances, 1, 2, 3, 4, 5, 6, 7. But they have to be equal distance. So you always have here, if this is 1 centimeter, then this should also be 1 centimeter, the same. And after, and of course you need a ruler for this, right? If you have an exam, you need a ruler for this so that you can actually start having equal, you know, space between these, values. And after that, put whatever you have here. Now, suppose you choose this centimeter, inch, 0.7 millimeter, has to be the same, which is different from what you're actually going to write. You're going to write something else. You're going to write the midpoint itself, right? The midpoint itself. You understand that? Okay. Same thing here. You design this, you know, to have the highest value of the frequency is 10. So this the 10 will be here. In the middle, this 5 will be here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that, approximately. Also with a ruler, you design this with a ruler so that you have, you know, good, you know, graph, good representative graph. And then you put the first value at the 0.7, it will be 4, so it will be here, right? And then the second is 2, so it will be here. And then you start connecting them as, yeah.
We can't put the class limits down.
In the midpoint, you can, but usually it's the midpoint. And instead of 0.7, you can write 0.5 till 0.9. But see, you don't have a space for this. You can, but it doesn't, you know, it's better to put the midpoint. Yeah. Okay, here you have to write this, like, for example, from 1 to 1.4, isn't it? But it's just not as nice as, you know, just putting the midpoint. Any question about that? So that was the question I gave you last time. Let us see another questions coming from previous exams. I just wanted to show you some of the questions that come from the previous exams. So, Ogive, okay, I still can bring this from one of the questions of previous exams. Let's see if there's an Ogive here. Let me see here. Just had a question now about Ogive. I don't know. It disappeared. Okay, anyways, I just close everything and open them all again, and hopefully I'll find it. Or maybe this is it. This is the construct of the Agile for the above distribution. Okay, this is the start for the exam 2011. Okay, just close everything. So if I just come here and was it here? No, it was a Word file. Maybe this one. I think I lost it again. Do you want ogive? It has to be ogive? Where is ogive? Okay, we can just solve any question, and then I can do the ogive as extra, graph. So let me just pick up any test here. I'll just pick up this one. Okay, and then I'll try to solve it and see what's the questions in there related to chapter 1, 2, and then see what's. So here's the question. Okay, the quiz is about chapter 1 and 2. So here's a question about chapter 1. Okay, and then we'll see something related to ogive. The Coca-Cola company has 366,000 stockholders, and a poll is conducted by randomly selecting 30 stockholders from each of the 50 states. The number of shares held by each sampled stockholder is recorded. حد فهم حاجة؟ Did you understand anything from that? Usually no. So what do we do in this case?
What?
Just read it again.
Okay.
Just read one more time.
It doesn't ask you a question, it just states some information.
He's just giving you some information, but do you understand the information given?
Yeah.
Okay, some people tell me, sir, I don't know what the stockholder mean. You really don't have to, okay, but you need to know, at the end, the question is asking about the population sample, so you need to know, and asking about the variable. Who's the, identify the population means, tell me what is the population. So, what is the population here? Yeah, the 366,000 stockholders, yes. So this is basically what I'm trying to, study, right? Information from those stockholders of the Coca-Cola company, okay? So this is my population. All the stockholders.
Yeah.
But I didn't get the information from all of them. I got the information only from some of them. The sample. What is the sample in this case? The 30 stockholders from each of the 50. So they are not only 30, they are 30 from each of the 50 states. They are actually 30 times 50. The sample is actually size 30 times 50. So it is the 30, so this should be the population. And this should be the sample. This should be your answer. This should be your answer.
So you don't have to calculate anything.
You don't have to calculate anything. You just say you identify. Tell me the population.
You just say 30
Yeah.
stockholders
From the Coca-Cola company, all stockholders of Coca-Cola company, like that. You can just say that in the population. And what is in the sample? You tell me 30 stockholders from each of the 50 states. Yeah.
What if we multiply 30 by 50?
You're bringing the sample size. If the question says, ask about the sample size, then you multiply 30 times 50. But it didn't ask about the sample size. Or the collected data size. Yeah.
For example, said the sample is the 30 stockholders.
Yeah. Not the 30. 30 from each of the 50.
From each of them.
From each, you see, the United States has 50 states, right? Like Kentucky, Maryland, Washington, California, right? So from each one of these states, there are 30 selected. Okay, so 30 from each one of the 50 states. Clear now? So that's about the population. Okay, This is sorry, that's about the sample. The population should be here, and the sample should be here.
This?
No, the whole thing, all this. This should be written here. Okay, and this thing should be written here. Clear that?
Yeah.
Now, are the values obtained discrete or continuous? The values obtained are discrete. Why is discrete? Because the number of shares, something is countable. 1, 2, 3, 4, 5 shares, 100 shares, something that you count, so it is actually discrete. Okay? Now what else? What type of sampling is being used? Of course, here we're not discussing sampling types because in the new book it doesn't talk much about the different sampling techniques. This one's called stratified sampling, but you don't have really to worry about this here. You don't have to worry about this here. Now this question uses data to construct a grouped frequency distribution using 6 classes. So here is the data. I'm giving you data. The inauguration age of some of the US presidents. I don't care about all this. I just care about, I have a quantitative data, and I want to construct a group frequency distribution with 5 classes. So that's another design problem. He wants 5 classes this time, right? And the steps are the same. So we start, yeah, exactly. It's looking for the lowest value and looking for the highest value. So what is the lowest value here, quickly? The minimum? 48? 45? 45. And the maximum value? Is 59. So the range will be R, which is 59 minus 45, which is equal to 14. So the class width approximately will be equal to what? To this 14 divided by the number of classes he gave you, which is 5 classes, right? You want 5 classes. How much is this? Approximately this is 2.8. So we need to round up to a value, a nice integer, because these data are integers, right?
Yeah.
So you round up to an integer, which is 3. So the class width will be actually equal to 3. If you don't have a clue what's going on, tell me, sir, I don't understand what's happening. Yeah. Class width. This is the class width. Class width. Okay, I just use the abbreviation class width. CW. Okay now? So I got the class width now. Any other questions you have? I just followed the rule of calculating the class widths. Now I got 3. I'm starting with the minimum, the value, which is 45. This will be the beginning of my first class. I'm going to write here 45. 45 like that, right? And this will be the beginning of my class limits. And then I need to keep adding 3, right? So when I add 3, I'll add it vertically. So just add 3 here. So this will become 48. The new class starts at 48, and then 51, and then 54, and then 57, right?
Yeah.
And then if the first class, it should end up at 47 because the next one, 48, right? And then I keep adding 3 as well. So this would be 50, 53, 56, and 59. And you need to make sure that at the end that the minimum is in the first class. The minimum is actually here, isn't it? And the maximum should be somewhere in the last class, and it's actually here, right? It doesn't have to be in the first value, second value, third value, but it should be somewhere in the first class. The minimum and the maximum should be somewhere in the last class, which means, you know, you're covering all the data and you're also having all the classes required, 5 classes. And you actually have. So this way you check that your design is correct. If something is wrong, you go back and modify this. You change the class width so that you have the required number of classes, which is 5 classes. And you cover the minimum. You have the minimum in the first and the maximum at the end. Now the frequency is the next, Sorry? 47 because if the second class starts at 48, okay, if the second class starts at 48, then for sure the first ended at 47. So any value 45 or 46 or 47 will be in the first class, but the values 48 and 49 and 50 will be in the second class. That's called the class limits, and that will help us in the tally, in the counting process. See, the next step is to actually start doing the counting process. So let's do the counting. Okay. I can't get this right. Okay. So here, 48, where is it? It's here, right? So I put a mark here. It's 48. And then 53 is actually here. I want to mark here. And then the 55 is in the next class. And then the 58 is actually here. And then again, 54 is here. 56 is also here. 51 is actually here. And 39 is here. No, I should make it another one. Yeah, like that. Okay. And then 52 and 55, one is here and one is here. 45 and 54, there's actually one here and one is here, the first one, yeah. So, see, you notice when I had 4 and the fifth one just come across them all. So you have like a pack of 5. And then 55 and 54, they will be here also. 55 and 54. And another 54. And then 57 will be here. And then 51 and 55, 51 will be here. And 55 will be also here. 59 and 56, 59 is here. And 56 is also here. That's it. Yeah. Now after that we do the numbers. After that we do numbers. We're counting like this first because I don't want to get confused. I make one mark here, one mark here, one mark. And after that you get the frequency. Yeah. So actually I'm going to replace this now with the frequency. So I'm going to write here the frequency here is actually 1. The frequency here is actually 2. The frequency is actually 4. The question here is frequency is 10. And here it is 3. Okay, so this is a frequency in black, 1, 2, 4, 10, 3. And if you want to make sure, you can just add them all. How much? You get 20 values, right? Which is the same as the data size. So the sum of the frequency is actually 20. And also the data size, which is n, also equal 20. Okay, so that means they are the same. So that's at least give me indication that I am probably right. I probably didn't make a mistake. Okay?
So the first one should be 2.
The first one should be 2. Why? I have only 145. Do I have another thing? There's only 145 there. This is 45. There is no other 45 or 46 or 47. Do you see any other 45, 46, 47 in the data? No. So it's only one value. Right? Any other questions? Yeah, now he wants the class boundaries and the cumulative frequency. Okay, the boundaries, yeah, they close the gap, or halfway actually in the gap, between 47 and 48. So this will be 47.5,
And 44.5.
and this will be 44.5 because you're actually using 0.5 as the half of the gap. So the same thing here, this would be 47.5, same value exactly. This would be 50.5. So you notice here 47.5 is the end of the class, and it's actually the beginning of the new class. The boundary exactly the same value. Yeah. Tell me.
But when would you use class limits and when would you use class boundaries? Do they perform different functions?
They do this, almost the same job. Some questions start with class limits, some questions start with boundaries. In the past we used the boundaries for graphing the histogram. I can show you now how. But it depends really on how do you want to display the data on the graph. And it depends also how the data is given. Sometimes it's better represented by class boundaries, sometimes it's better represented by the class limits. Okay, so in the counting process, in the tally process, usually we use the limits, as you have seen here, right? But sometimes the table is given ready. You don't have to count or do tally or anything. In this case, it can be given as limits or boundaries. Yeah, so questions sometimes start with the table. Here it didn't start with the table. Here the question started with the data, the raw data. So you have to do this counting process yourself. It's as you can see, I use the limits in the counting in the beginning.
It all just depends on what you ask us.
Yeah. But I mean, the limits are usually the one that people are interested, in, because they give you clear distinction between what's in this class and what's in the other class.
So in all cases we should use the class limits.
Usually, yes. In all design cases, you should use the class limits. Yes. In all design, yes.
How many credits are we going to take?
Sorry.
How many credits are we going to take?
2. One now or one after the midterm. Yeah.
But
But don't cumulative frequency ogives use only
The upper boundary.
boundary?
Yes, exactly. So it depends on the graph, as I said. Yeah, the graph requires upper boundary like the ogive. So in this case, you need to, but even if you make design, you still have to do the design using the limits and then calculate the boundaries for the ogive. So we can actually start doing the ogive here, even though it's not required, just to show you how do we graph the ogive and why we need that, okay? Since we have the cumulative frequency anyway. So that's the class boundary. You can continue doing this until the end. Okay, so the end will be reaching here. I'll just continue the upper boundary by keep to add 3. So this will be 53.5, and this will be 56.5, and this will be 59.5. Okay, I just did the upper boundary, keep adding 3. The cumulative frequency is to add up the frequency. So here I have the frequency of the first class only. Here I have the two classes, the frequency of two classes, the first two classes, which is 3. And then I have the frequency of the first 3 classes, which is 7. And then I have the frequency of the first 4 classes, which is 17. And then I have the frequency of all the 5 classes, which is 20. And as you can see, this is also equal to the data size. Don't forget that, right? It's always that some of the frequency are some data size in. Okay? Yeah. See it again? I just keep adding the frequencies. So here I have the first class only, which is 1. Here I have the first class. Here I have the first plus the second. Okay? Here I have the first plus the second plus the third. I just keep adding the classes frequencies. Okay? So it's called cumulative, which means you just keep accumulating frequency. You just keep adding frequency. Instead of just writing the class frequency, we just write the accumulated frequency. Okay? Any question about that? So that's how we did the table, that's how we did the design. Now the second question, he said construct the histogram. You want to see the histogram. Yeah, this is like a bar for each class. Okay. So here the design problem, you need, remember how many classes we have? 5 classes. So here you don't have to worry about it. Just put 5 classes with equal distance. That's it. That's all what you have to do. Okay. And then again, remember here, this can be inch, so they all have to be inch. If the width is 5 milli, it should be 5 milli with a ruler. Yeah. And then after that, put the value. So when you put the value, you can choose to put anything. You can choose to put the class limits or the class boundaries, right? In this case, in the past, we used only the boundaries. Now with the new book, you can put anything. Remember, the new book has more flexibility in that. Yeah, class midpoint, class boundaries, class limits, anything. Yeah. But be careful, if you use the midpoint, then you should put the bar like that. Right? So that put the point in the middle. If you, but here I will actually want to use the class boundaries. No, because we already calculated the boundaries, and this is all the way of doing things. So the boundaries here will be from 44.5 to 47.5. So here this will be 44.5. This will be 47.5. The next one, just keep adding 3, right? So this will be 50, 53, 56, and 59.5. That's it. So the last value will be 59.5. Just keep adding 3. It's only writing because you're already prepared.
Use the class width, right?
You mean the limits, not the widths. You have to put values for each class. Different value for each class, representing the class, which is either the boundary or the limits or the midpoint. So if you use the boundaries, that's how you do it. If you want to use,
I think the limit. We can use
this is, yeah, if I want to use the limit, it can be like this. You can say 45 till 47, first class.
Okay.
And then here this class will be, but you don't have a space, you're making things a little bit harder. From 48 to 50, and then here you're going to say, okay, I have this from 51 to 50, 51, 3. But you're really going to run out of space here. It's not really convenient. Yeah.
Shouldn't be the last class 57.5?
Yeah, I'm using the upper boundary here.
Yeah.
I'm using the upper boundary here. So let's put the values. Remember the frequency, what was it? It was from 1 to 10, the highest value is, so suppose just prepare the scale also, same thing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Approximately, okay? Equal distances also. So if this is the case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I'm going to put the first was what? How much the frequency of the first one? Was 1. So the first one will be from here like that. That's the first bar. Okay?
You're using the boundary, right?
I'm using the boundary here. Yeah, I wrote them already. So remember, yeah. After that was 2. Okay, and then the next one will be 2, and then after that 10 or 4. Let's just check. Let's just check. Okay, 1, 2, 4, 10, 3. So 1, 2, then the 4 will be almost here, and then you just come down here, and then after that you go to the 10.
So we have to stick them together, right?
Yeah, well, again, this is one of the options. If you use the boundaries, stick them together.
Okay.
If you use the limits, leave gap. Yeah. But again, this you don't have to. You can still use the limits with no gap because
We choose the midpoint.
you choose the point. Just put the midpoint in the middle here,
Okay.
like that. Here. Suppose I want to use a midpoint, so I put this mark here, put the mark here for the midpoint. And the midpoint for the first class will be what? Will be 46.
Yeah.
So I'm going to write here 46 for the first class, and I'm going to write for the next class 49, and so on.
Midpoint.
Yeah, the bar should be centered around the midpoint. Remember? Okay, so that's also choice. Okay. Again, the new book is giving you a lot of choices how you do that, but the old one we just use the boundary only, nothing else. So, and then finally it was what? The last value was 3. So just come here and it's 3. That's it. So this is a histogram in this case. This is a histogram in this case. Okay, any question about that? Now someone wanted to do the ogive, right? You want the ogive. So let's do the ogive also. Let's just do the ogive here. So if I want to do the ogive, this is a histogram now. This is a histogram. If I want to do the ogive, then I will use only the upper boundaries, right? So I put the same boundaries here, okay? Which are same thing, 44. I'll just use the same scale, okay? I'll just use the same scale. Okay. I'll just do it here. Okay. If I want the ogive, then in this case, the boundaries, the first class was what? 44.5. Start and then end at 47.5 because the class width is 3, right? And then the next class, and then the next class, and then the next class, and the next class, next class. How many classes? 1, 2, 3, 4, 5, right?
We'll use the community.
So this was 40. The last one was I think 59, like that.
Yeah,
59.5 here. So we use exactly here the cumulative frequency, and here we use the upper boundary. And in this example, we already calculated the upper boundary, right? So in this case, I'm just ready to use it. The cumulative frequency, the frequency was what? 2, 4, or 1, 4? Let's just go back. Look at that. It was 137.17. This is the cumulative frequency, 137.17. So here I'm going to have, see the maximum here is what? Is 20, right? Because this is a data size. And here 10. Okay? And if the data size is only 17 or 18, you don't have to end up at 17. You can still end at 20 because it's a nice number, easier to make it a scale, and then the 17 will be a little bit below, which is okay. Understand? So you use a nice number when you design your scale, and then the points can be anywhere. So here, I'm going to just put this maybe 2, 4, 6, 8, and then also 4, 6, like that, approximately. Khalas? And I said 137, right? So 1 will be here. Remember, it's upper boundary. 3 will be here, approximately. and then 7 will be here, almost, right? And then 17 will go up, right? 17 will almost be here, okay? And then finally I reach to 20, okay? And then I connect them together like that.
Without closing, right?
Without closing. But the first part, because it's starting from the beginning of the class, it was 0, there was no frequency then, so you can close it like that, okay? So this will be the ogive. Yeah, this is the first class lower limit, lower boundary here. This is the first class lower boundary. The beginning I didn't have any frequency here, 0, okay? So here this is 0 frequency, use frequency. In the first class, and remember this is the first class, lower limit and upper limit, and after that just for the upper limit you keep doing this, okay? Any question about that? That is the ogive in this case. The question didn't ask for the ogive in this exam, but because some people are interested to see the ogive, so that's how you do it.
So concept for the ogive or ogive, or however you pronounce it, you use the lower boundary, you start with the lower boundaries.
You start with the low boundary of the first class, 0.
Yeah.
Because you haven't accumulated any frequency yet. And after that, for each class, use the upper boundary with how much you have accumulated frequency. Okay? You always use for the cumulative frequency, yes. For the cumulative frequency, which is 137, use the upper boundary. So when you graph, actually, if you go back to the table, actually graphing the upper boundary with the cumulative frequency. So this will be the horizontal or the x-axis, and this will be the y-axis, the vertical axis. That's how you do the ogive. That's how you do the ogive. Okay, you use these two together to do the ogive. Any other questions? Again, this doesn't, the exam itself, remember we are solving one of the questions in the final exam in one of the years. I'm just taking from some of the final exam questions to show you how does it look like, because the quiz will be a mix of questions. Some multiple choice like the one we did in class or at homework, and some will be like this, like the one comes in the final exam, so we'll be trained to both. Okay, the question will be a mixture, the questions will be a mixture of both in the coming quiz, inshallah. So I just wanted to show you how the questions come in the final exam.
It will be on Tuesday, right?
Yeah, it will be next class. Yes, next class on Tuesday. Yes. Yeah, you have a question?
Are we going to need to show working for the table?
You mean, yeah, if I ask you for the table, or even if I ask you for the ogive, well, if there is anything wrong with the ogive, then you lose the mark. But if you show me the table, at least you show me the work, then yeah, it's recommended. Any open-ended question, it's better to show me the work, because if you have a small mistake, I can still give you a partial mark or sometimes even the full mark.
Yeah.
But if you don't show me the steps at all, and you have the final result is wrong, then you lose the whole thing. So it's not a good idea not to show me the steps in an open-ended question, okay? So that was one of the questions. I just want to see what else here related to chapter 1 and 2. Maybe that's it. Okay? Let's see another one? Another exam? Yes? The exam final, one of the final exams. We're just looking at final exams came before. Okay? This one say I have the World Cup Cricket Stadium. The World Cup Cricket Stadium had 4 entrances for the spectators to enter. From the 4 entrances of the age of 10 spectators are collected. So this is 2 sentences, the first sentence and the second sentence. So I want to answer the following question. First of all, again, what is the population? The population, read it again. See, if you don't understand the question, read it again.
Everyone who entered the 48.
Spectators. Spectators, yeah.
Huh? Spectators.
Yeah.
All the spectators. The population is all the spectators. And I don't know if there are 14, he didn't say. He said only 10 are collected, yeah, as a sample.
Yeah.
But how many are there? They didn't say. They just said 4 entrances for the stadium, but this is not about the entrance. The population is not the entrance. The population is the spectators, right? So we don't know how many of them, and I don't ask you for the number of them. I'm not asking you to count. I'm just telling you who are the population, who are this study is about. This study is about the spectators, the cricket stadium spectators. Simple as that. So this will be the first question. Identify the population. It is all spectators. How many we don't know. The second question is, what type of sampling is being used? Of course, this question, we don't have any types of sampling anymore because we don't use this in the new book. But in the old book, we used to have a lot of sampling techniques. Yes? The population, the data collected from who you are trying to study. We study the data. What did you collect actually? From the 4 entrances, the age. We collected the age of 10 spectators. Collected the age of 10 spectators. So we selected 10 from the total to get the age from. So who are we studying actually? We're studying the spectators. Even though we only asked 10, but this study is made about all the spectators. From these 10, we try to get an idea about the age, basically. We cannot ask everyone, so we got an idea about the age from these 10. So that's called my population. The population are all the elements that are meant to be, carrying the data for your study. Yeah. Su'al? Khalas? Any other questions? Statistical study, observation, experimental. Again, this was one of the things in the old book, so you don't have to worry about that also because it's not anymore in the new book. So chapter 1 becomes very small and light. Identify the variable under study. What is the variable we're trying to study? Just go back to these 2 sentences. What are the variables in this study? The age. Yeah, the studying the variable here is the age, right?
So the sample is 10, right?
Yeah, the sample size is 10. Sample size is 10. Not the sampling technique. The sampling technique and the method is different. Okay?
So it's not included
It is not, because we didn't study all these sampling techniques. We used to have a lot of sampling techniques before. Stratified cluster, convenience, and all these things are not anymore in the chapter. Okay? So we only studied random sampling, only one type. So random sampling is not the only way to do the sample. Okay? It's a good way, but it's not the only way to do it. Now the variable is the age. By the way, this variable is quantitative or qualitative? The age here is quantitative or qualitative? Yeah, it's a quantity, right? The age is quantity. Something that increase and decrease, something that, yeah, it's a number, numerical value that represents quantity. Qualitative is only like colors, names. These things don't have a higher value, lower value, that one is higher than another. You don't have like that. But the age, you have people who are older and younger and so on. So this is, of course, quantitative variable. So that's about, again, that was one of the final exams in one of the previous years. Now, this one is not related to chapter 1 or, this one also not in chapter 2. This is not in chapter 2. This one is chapter 2, isn't it? Here you're giving you 2 data sets and he wants a stem and leaf. Not any stem and leaf, he wants back-to-back stem and leaf. So if you have 2 data sets, exactly, then you have to have the stem in the middle. You have to have the stem in the middle. Let's do that because it has some small, it's a simple idea, but it can be a little bit tricky. So what are the stems here?
1, 2.
Yeah, start from 1, exactly. So 1, 2, 3, 4, 5, 6, right? Anything else? This is the highest value. Okay, so that's the stem in the middle. Now, for variety 2, the data will be, the leaves will be on the right, while for variety 1, the data will be on the left, right? So in this case, take this value, for example, 18. The stem is 1 and the leaf is 8. So where are you going to put the 8? Yeah, on the right here, right? Because on the right, I put the variety 2. And then 12. So let's do that. Will be 2. And then 67. The 6 has a 7 here. And then the 2 has 3 here. No, I'm doing this in order. 43, the 4 has 3. I finished the first column. Now I go to the second column because by order, if you don't do the order, sometimes it's faster, but you might make mistake. Okay, it's up to you. I choose when the data is large. I like to do that in order so I don't make mistakes. 36, The 45, I didn't do it. And then the 36, we'll have a 6 here. And then the 17, a 7 here, and so on. Okay? So anyway, once you finish this, what do you need to do?
Make it very good.
You need to arrange. You need to arrange. So this 827 should actually be written as 278. This should be written as 278. I don't know if I can easily erase this or not. Sometimes eraser doesn't work. Okay, this will be 278, right? And so on. If this is all the data, because I think there could be more. Let's do the other side. Variety 1. Let's do the first value here, the 12. Who is the stem?
2.
The stem is 1 and the leaf is 2. So where are you going to put the 2? On the right or on the left? On the left. See, it looks like 21, but actually it's 12. It's tricky. Right? And the 43, who is the stem? The 3 or the 4? The 4 is the stem, which is this one. And then the leaf will be on the left. You think when you read this is 34. It's actually 43. So you be careful when you do on the left side. Okay? And you keep doing like this. So the 5 has 9. The 19, 1 here, 9 here. 34, this is the 3, the 4 here. And then the 20, the 2 zeros here. You see what's happening?
Yeah.
51, the 5 is the same. You put the 1 here. And then after you finish, you arrange them also. So see here, 9 and 1, it should actually be what? It should be actually, after you arrange it, it should be 1 and 9. Because you arrange from right to left in this case. So there's 2 steps here. You accumulate the data, get the leaves, and after that you arrange. When you arrange on the right, it's different from on the left. The leaves increase as they go far from the stem. The leaves increase as you go far. So here this is a far direction, right? But here this is a far direction, so that's how you are increasing the leaves. Okay? Yeah. The stem, they are basically, when you divide each of these numbers into 2 halves, this is a stem, this is a stem, this is a stem, this is a stem, this is a stem. So I found the stems to be from 1 to 6. The smallest value is 1 and the biggest is 6. So I have to put them all from 1 to 6 here. Okay? Any other questions? Khalas? Clear now how to do the stem and leaf?
Yeah.
Is there another question? Khalas? Okay, you got the idea? So I think you have, this is another question here, construct frequency for the variety 1. So you go back to the variety 1. It's actually like a second part. You go back to variety 1 and make a design for how many classes he said? For 5 classes. So you need to go back here and make a same design one more time for 5 classes. Right? It's just to do the design and let you continue this at home. What is the minimum value for variety 1? 11?
Yeah.
12? 11 the minimum, smallest value. What's the biggest value? The biggest value is 59. So I need something to cover from 11 to 59. So let's do the class widths. Class widths. The range will be 59 minus 11, which is equal 48. Right. The class widths will be divided by, divide this for 8, divided by 5. Okay. So this how much? Give me about 9 point something, right? 9.6 maybe. So you round up to an integer because all the data here are integer. See, this is integer, no decimal values, right? So round up this to an integer, so the class actually width will be equal to 10, right? Okay. Khalas? So that's it. So start from 10. The smallest value is 11. So you just go back from you go to 11, starting from the 11 here, right? Starting from 11 here. Don't know why it doesn't work. And then you just keep adding 10 down. So this will be 21, 31, and so on. And of course, if the second one starts at 21, the first one will end at 20. So it has 10 values, right? Same thing, keep adding 10, so this will be 30. Keep adding 10, so it will be 40, and so on. Clear how you do that?
Yeah.
Professor, is it acceptable to fill out the table in pencil?
Yeah, I use pencil or pen. For me, it doesn't matter. It's up to you, yeah. And in the frequency, as we did before, the counting and the boundaries, you don't have to do with the cumulative frequency, just did that. So if you look at some, I'll put these final exams on course materials. Hopefully, I'll put also this solution. If the recording work, I put it as a video, so you can watch it. Or anyone, if someone missed it, you can watch it again. But anyway, with the final exams, you can see how the question look like. So you have two types, multiple choice and this kind of question. Yeah.
Sometimes the multiple choice is your answer. The word is then.
No. This was a mistake, and I removed this from the future questions. The class can be represented in different ways. You can use boundary, limit, midpoint, anything. Anything. Yeah, you don't have to. Thank you. So next class is the quiz. Okay, on Tuesday. Thank you. Don't forget homework 2, please. There is homework 2, cumulative homework 2. It's at the end of the week, but it's better to do it before the quiz. Huh? It's better to do it before the quiz.
Enough to just watch your YouTube video.